To anticipate climate changes and their consequences for the natural cycles of water and forests, for example, scientists use digital models which enable them to perform simulations. But are these models really dependable? And how can they be tested? How about going back in time to study the most rapid climate changes in history? That's the aim of the FATES project. Coordinated by the Laboratory of Climate and Environmental Sciences, the project will bring together multidisciplinary research teams at the University of Paris-Saclay for 3 years. The objective of these scientists is to study the last major episode of natural global warming, which took place somewhere between 10 and 20,000 years ago. The initial cause of this warming is known to have been triggered by an increase in summer sunshine at our latitudes, the result of slow changes in the Earth's orbit around the Sun. And this was amplified by climate change feedback. For example, melting ice increased warming by reducing its mirror effect. Water and carbon cycles were affected, increasing levels of greenhouse gases and thus global warming. The melting of the ice caps covering North America and Europe led to a rise in sea levels and changes in the structure of ocean currents and winds, with spectacular regional consequences, as with the development of the European forests. Thanks to the FATES project, these past changes can be accurately dated and characterized. How? Thanks to the analysis of the number of natural climate archives, such as those found in the polar ice, sediments at the bottom of oceans and lakes, and stalagmites in caves. This new information will allow us to gauge the magnitude and the rate of climate upheaval. Parallel to that, the same indicators measured in natural archives, oxygen and carbon isotopes, etc., will be incorporated into climate models, allowing calculations to be compared directly with the information drawn from natural climate archives for the first time. The models used to explore the future evolution of climate and of European forests will therefore be used to simulate the great changes of the past. This will lead to a better understanding of climate history and allow us to test the reliability of these models in predicting the extent and rate of change, thus giving us a better grasp of future developments.